Welcome to a presentation of PV fire safety. What you are about to see is a demonstration of the risk of arc faults inherent within two inverter technologies. In this demonstration, we have a meter, a scope, and a gap to simulate a wiring fault. The experiment will begin with no gap. The rods will then be slowly pulled apart, simulating an arc gap from a wiring fault, such as a loose connection. In both cases, inverters are exporting power from the solar modules to the utility grid. The first case simulates a string inverter scenario. The inverter is exporting 2 kilowatts to the grid. As we establish an arc by simulating a wiring fault, the arc gets hotter and hotter. Temperatures can reach up to 4,200 degrees centigrade. This is hot enough to melt tungsten. The second case illustrates a microinverter scenario. The microinverter is exporting 170 watts to the grid. As you can see from this scenario, only the smallest of arcs is visible, and for a very brief moment. The nature of a microinverter is that the arc is self-extinguishing. Here is another look at the two scenarios side by side. We hope this helps illustrate the differences in arc fault risk in the two inverter technologies.